Okay, so I had several students who wanted to know how to do this type of a problem, okay? Here we've got f and g linear functions. They give you the graphs. They don't actually give you the equations of the functions, but then they define this third function, q, as f divided by g, right? And they want to know the value of q prime, or the derivative of q, at 2. Now, I had some students ask me, how can I do this problem just by looking at these two graphs, you know, and seeing this? Not sure where they're getting that from. I can't do that. I'm going to have to do this kind of the hard way, okay? So f, because it's linear, and, you know, the reason I put this grid up here is so that you could kind of see the way they give you the function. You can tell that the slope of this function is 1, right? Because it hits all the, you know, the diagonals in the little square. And of course it crosses the y-axis here at 2, so the equation for f is going to be x plus 2. 1x plus 2, 1 is a slope. G, also you can tell that, you know, it's rise over run, right? So it's negative, it's got a negative slope. Down 1 over 2, down 1 over 2. So this has a slope of negative 1/2. And it crosses the y-axis here at 3.5, because it's right between the two points. So we can define q as f over g, just plug these in, all right? So now we have q. To get q prime for something like this, I would use quotient rule. Okay, now quotient rule, to me, the easiest way to use quotient rule is to make a form. And there's my quotient rule form. Okay, now all I have to do is fill in the blanks, all right? Quotient rule always starts with the bottom. That's the other thing that you have to remember. You have to know what the form looks like, and you have to remember that quotient rule starts with the bottom, okay? So we take the bottom here, and we put it here and here, okay? Okay, so that's where the bottom goes, okay? Next thing we do at the top, x plus 2 goes over here. So, you know, here we've got, 3/5 of the quotient rule done just by filling in the form. Now we have to take a couple of derivatives. The derivative of x plus 2 that goes here, that derivative is 1. The derivative of negative 1/2 x is negative 1/2. The derivative of 3.5 is 0. It's a constant, right? So this is q prime now, all right? So we want q prime of 2. We can use a calculator. We can just plug 2 in here for x, okay? And then we can get q prime of 2. So this is how I go about this. You know, f over g is not linear, okay? If you look at g crosses the x-axis here, okay? So this is actually going to be a vertical asymptote of q. So here, f and g are the same, so they're going to have a value of 1, okay? So q is going to look something like this, okay? So to just be able to look at q and say, oh, the slope is going to be something, in general, I don't think you want to try to do that. Find f, find g, get q, use the quotient rule to get q prime, plug into the calculator, and you'll get the value of the slope. You can tell, though, I mean, that it's going to be positive, right? And, probably less than 1. You can get some information about it from the graph, but I wouldn't try to nail it just by looking at it. The one they give you on the problem, there's some other stuff out here, okay? These functions change, you know, they go like this. This is no big deal. You just start over from here and you do the exact same thing, okay? And then if you have another place where they give you different functions, this is a graph of a piecewise defined function, basically. If you have any more questions about this, send me another email. I'll explore this topic in greater depth.